Variance is a number that gives a general idea of how spread out the values in a dataset are. A variance of 0 means there's no variability. That is, all the numbers in the dataset are the same. And the larger the variance, the more dispersed the data is. The spread of data tells us how much the individual members of the dataset differ from the mean. It's a statistical measure that's often used in population studies. First off, there are basically two types of variance figures: population and sample. Population variance means that every member of the population is shown in the dataset, and sample variance means that the data was extracted from a sample of the population. An example of population variance would be using the math exam scores from all the schools in a school district as a measure of that district's math performance. And an example of sample variance would be using the math exam scores from 4 schools in the state to measure the same thing. The key thing to remember is that if the data is supposed to tell a story about a larger group, then it's a sample. But if all the members of the population are shown in the data, then we're calculating population variance. We can calculate population variance manually by doing the following. First, we find the arithmetic mean, which in Excel means just finding the average. The second thing would be to subtract the arithmetic mean from each value. So let's do that here. Third, we'll want to find the square of each difference. So we multiply each one by itself. And finally, we find the sum of all the squares. And divide that by the number of values in the dataset. This tells us that we have a population variance of 40. With sample variance, the process is the same, except for the very last step. So let's go through those steps one by one. First, we find the arithmetic mean, that's the average. Then we subtract the arithmetic mean from each value. And then we find the square of each difference. Now we're at the last step. We'll still find the sum of all the squares, but instead of dividing by the number of values in the dataset, we reduce that number by 1. So we'll count how many values there are, in this case 4, but we reduce that by 1. The reason for doing this is that since we don't actually have the information needed about all the high schools that we're interested in, we'll have to account for the unknown in our calculation. So we have a sample variance of 77. You'll be relieved to know that Excel takes all the manual work out of variance calculations with its pre-built functions. Excel has 6 functions to calculate variance. The function you choose depends on the version of Excel you're using, whether you want to calculate population or sample variance, and how you want Excel to handle text and logical values. You'll notice the yellow triangles here. These are the VAR and VARP functions. They're being phased out, starting with the 2010 version of Excel, so we'll concentrate on the 4 newer versions for now. Unless you only have access to these 2 older versions, it's recommended that you use the newer ones since they give you greater flexibility, and it's not sure how long Microsoft will continue to support these older versions. Now, all 6 functions have the same syntax. The general format is equals the function name, open parenthesis, list of values, close parenthesis. The formulas accept up to 255 arguments. All the variance functions ignore empty cells. Now let's apply these functions to the examples that we just calculated manually. We'll start with our sample variance. And the VAR.S function estimates variance based on a sample. So that's the one we want. We select VAR.S, open parenthesis, and our range. And we've arrived at the same figure that we got when we did our calculation manually. We chose VAR.S because this is a sample, and we're using the 2019 version of Excel. Versions before 2010 would use VAR. Let's see what happens if we use the VAR function. The result is the same. Now let's switch to our population sample, and the function we'll choose here is VAR.P. It calculates variance based on the entire population. The reason we're using this is because our dataset represents the entire population we're reporting on, and we're using the 2019 version. So we select VAR.P, select our range, and we have the same as what we calculated manually. If we were using a version of Excel before 2010, we'd use the VAR.P function. Let's see what happens. And as expected, our result is the same. Now let's look at how each function treats text values. Let's add another row of data. We'll call them Carson High. That submitted no scores for math. How would that affect our variance figure? Now that we've added a text value in cell B11, let's see what happens if we expand our range to include that cell. Well, there's no change because both functions ignore text values. But now, what about the variance functions that do take into account text values? The VARPA function does evaluate logical values and text. So let's select VARPA and our entire range. Well, now we have a figure that's quite different from the other variance results that we got. The reason for this is that variance is used as a prediction tool by investors and statisticians. So when we have a large variance number, this is a risk indicator. We don't know why there's no math score at Carson High, so we may want to account for its absence by using this function. But what if we do know that Carson High doesn't offer a math option? Then their lack of a score doesn't really impact the story here, so we wouldn't use VARPA. But if they do offer math, and maybe the students didn't show up, or for some other reason that grade isn't shown here, then we'll decide whether we want this NA value to be ignored, or we want it to be treated as a 0. If there's text, then functions which evaluate text and logical values will give text a value of 0, false a value of 0, and true a value of 1. So if we want this to be treated as a 0, we'd use the VARPA function. And the same applies with sample variance. If we had an NA here for Carson High, the VARA function will evaluate that text value as a 0 and give a large variance figure. But if we expanded that range with our other functions, there'd be no change. Well, that's great. But what exactly does a variance of 40 or 77 mean? If we remember, the calculation of variance is based on squared values. So if we find the square root of the variance, then we'll have some figures that we can start to work with. Let's see what happens when we find the square root of our sample variance. Well, we have 8.8 here. This is the same as standard deviation. Now the units are the same as the original dataset. This is a measure of how far the typical values tend to be from the mean. So standard deviation is a prediction tool. It's saying that the values are about 8.8 around the arithmetic mean. Standard deviation is easier to understand than variance because it tells the story of the degree to which data can vary from the mean of the dataset. But we need to understand variance before we can understand standard deviation. Now that we've broken this down for you, are you ready to tackle some more statistical Excel functions? Come browse our resources and course library to get started.
Ready to learn more about Microsoft Excel? Then check out the full course on GoSkills.com. Click the link in the description.